This is the Theta Institute, and today's topic is electromagnetic devices and circuits. So, we have to elaborate these electromagnetic devices and what are the circuits. Electromagnetic devices. The electromagnetic devices are many in number, however, we will take a few in consideration which are of daily importance routinely used in these circuits. Number first is the resistor. Resistor or the resistance, and second is diode. Third is the transistor. Fourth is the inductor. And fifth, we may take the capacitor. These devices, which are many in number, for example, resistor is a device which, when put in an electric circuit, it offers resistance to the flow of the electric current. Resistance means it blocks the electric current according to its power. The blocking power of the resistance is according to this power. So resistance offers the blocking power to an electric current. It blocks the flow of electric current according to its power. More the power of resistance, more the power of a resistor, the more will be its blocking power to flow the electric current. And diode is a device which occurs one way flow from positive to negative. That means if a diode is connected in a circuit, this is positive and this is negative. When diode, it is composed of a PN junction. This is P and N. Electric current will flow from P to N but not from N to P. One way, from positive to negative. So diode is a device which allows the electric current to flow from P junction to N junction but not from N to P, but not in reverse direction. Now, a transistor is a device which is which is made of three junctions, two junctions rather, three pieces P, N, and P, or alternatively N, P, and N. Transistor is a device which is made from three components. If this is green, N, this is red, P, and this is again N. N, P, and N. This we may take as a transistor made by connecting NPN, NPN in this way. So as this junction is N and P junction, then this junction, the connection between P and N is PN junction. So two junctions, two unions are formed by joining three pieces of N type material and P type material. That is two pieces of N type material are connected in between by a P type material, or two P type materials are connected in between an N type material. So what we mean to say that a transistor is formed from three pieces, either of two N and one P, or two P and one N type material. In this way, two junctions, two unions are formed by this arrangement of three pieces. This transistor, what it does is that it has many applications in current electronic era. For example, it is used for amplification of a weak signal, and also for production of oscillating waves, for oscillation, for making an oscillation or making an oscillator. Oscillator is a device which makes an electric oscillating signal. Those oscillating signals are having many uses, from communication to today's computer era. So now we come to an inductor. Inductor is a device which is a helical conductor. Helical conductor. A conductor coiled on itself. It is inductor. For example, this is an inductor. What are the uses of this inductor? Is that this inductor offers a delay to the flow of electric current. It offers a delay to the flow of electric current, just in the same way as a thread, just in the same way as just in the same way as long will be the turns is equivalent to as long will be the thread. If many number of turns, then long equivalent to long thread. A long thread will offer maximum delay. A short thread will offer small delay, and even shorter thread will offer minimum delay. So a smaller coil will offer lesser delay. For what purpose are these coils used in electronic circuits? To offer delay in flow of electric current. And then is the capacitor. Capacitor is made of two parallel plates. Parallel plates. For example, if these are two parallel plates, two parallel plate conductors, when they are brought near together and connected by two wires and connected by two wires, two conductors, if this is one conductor, one conducting rod, one conductor here, another conducting rod and another conductor of surface area, maximum surface area or much surface area, conductor with a connecting rod of conductor, conductor plate with a conductor. Now, when these are brought nearer in space, nearer in space, a little space is kept in between them. A little space is kept in between them. What happens when we will apply charge, positive charge to one and negative charge to one? In other words, when we will apply DC voltage across these conducting rods to these conducting plates, which are held at a minimum distance apart, this charge gets stored between these plates, not in air but on the surface of these conductors. Negative charge gets stored on negative plate, positive charge gets stored on the positive plate on the surface, but they should be close to each other. What we should do for that purpose is that we should get a piece of paper. We should get a piece of paper in order that these conducting plates will not get short circuited. We have to place one paper in between these plates, in between these conducting plates connected with two conductors. This is one conducting plate, this is another conducting plate. Now we keep them close together, separated by paper. Why this paper? Because they should get closer to each other without getting physically contacted to each other, electrically contacted to each other. Then there are two rods, then there are two connecting rods. One is this and one is this. One connected to the positive plate, another connected to the another plate. When positive signal is given, for example, suppose to this red one, positive electricity given to this red plate and negative electricity given to this black plate. What happens? Positive charge gets stored on this black plate and negative charge on this positive charge gets stored on this red plate and negative charge on this black plate. Even after we take the charge away, even after we take the DC current away. So that is the purpose of condenser or capacitor. It stores electric charge. Okay, let us show it on the board. One plate and this is another plate. These two plates, are connected externally by a cell or battery, positive to this one and negative to this one. What happens? Positive charge gets stored on this plate and negative charge to this plate, but they should be kept close together. Rather, we should keep a piece of paper in between. Then what happens? Positive charge gets stored here and negative charge gets stored on another plate. This is capacitor. So capacitor we are showing by symbol of two parallel lines in a circuit. However, the resistance we are showing by a line, then of these up and downs, and that line continues. This is the symbol of a resistor. And what is a diode? Diode is made of two junctions of p-type material and n-type material. Later on, we will talk about what these actually are, what is a p-type material and what is an n-type material. But for this time, you remember that a PN junction or PN diode is made up of two materials, P material and N material, applied together, connected together, so as to form a junction between the P and N. Let this be a P junction and this be an N junction. This P junction and this N junction. When held close together, what we get is a PN junction or a PN diode. It is symbol P by arrow and N by a strip. This is a P and N, PN junction. The symbol of PN junction or PN diode in an electronic circuit by this symbol. From P side an arrow and from N side a vertical small line. For transistor, there are three junctions, PNP or NPN. P, N and P. One wire there from N, one wire from this one, this P, one wire from this P, and one wire from central N. PNP, PNP junction, PNP transistor has two junctions. One junction is between P and N, another is between N and P. Alternatively, a transistor may be formed by NPN junctions, NPN transistor. In this way, these are two N junctions on either side and a P junction in the center and a P junction in the center. This P this P type material in the center, P type material in the center, and two N type materials on either side form N, P and N transistor. N, P and N transistor. The symbol of transistor in the circuit is shown by a rounded circle with, here it is a base, this is collector and this is emitter. Base, collector and emitter. The central one is base. Here is central one base. Central one base, central one base. In case of PNP transistor, in case of PNP transistor made of two P materials, in between which is placed N material, in the middle of which is placed N material, the middle one forms base. Similarly, in NPN transistor, the middle one P forms base. The left one P in PNP forms emitter. The left one in NPN, that is N, forms emitter. The right one in PNP, that is the P, right one P. Here in PNP transistor, the right one P forms collector. In this NPN transistor, the right one, NPN, in NPN, the right one, that is the N, it forms collector. So a PN junction or PN diode is made of only two materials, P and N material. And the transistor is made of three materials, three pieces, two pieces of either PP, in between a third piece N, or two materials of NN and a third piece of P in between, different in between. Now these are the main things which are used in the electronic devices. We in this unit will learn some basic circuits of this electronics. And indeed, we will show you how to produce the electromagnetic oscillating waves, radio waves, and how to amplify these waves, and how to produce oscillators, how to make oscillators practically. And in later sections, we will show you the basics and even the details of a computer. Now let us rub it off. Now let us take the example of an amplifier. How an amplifier is made, what are its ingredients. First of all, we will see that a microphone. Microphone is a device which has a piezoelectric crystal in between two wires. What is a microphone? It is a device which has a piezoelectric crystal in between. Whenever we speak in front of that microphone, for example, this is the microphone. This is a microphone. It has, in this plastic cover, there what is inside, there is a piezoelectric crystal. In this wire, it is not a single, in between there are two wires. Two wires go in this black wire, pearl. Two wires go inside this device. What happens? Two wires are inside this device. There is a piezoelectric crystal. These two wires are connected on either side, on each side, on two ends of the piezoelectric crystal. When we speak, that crystal gets compressed and relaxed, compressed and relaxed. By compression and relaxation, it makes electric signals. We will teach you later on. So by showing this has partially gone out. Now we are replacing it back in the original position. Huh? This is our microphone. Let it be in good condition. And microphone, we have asked, we have told what is microphone. Then we have to also learn what is a speaker. How do we hear? What is the device which speaks in a device? That is called a speaker. Speaker is made up of three things or four things. One is support. In the support, what is it? Is iron support, and there is a magnet, coil, and a diaphragm. Support, magnet, coil, and a diaphragm. The active ingredients are magnet and coil. Diaphragm vibrates according to the vibration, according to the motion of coil. What is a loudspeaker or speaker? Here in this speaker we have a bar of magnet with a north pole and south pole. Bar of magnet, north pole and south pole. And then underneath with support, this bar of magnet is supported. What is it? It is supported here. This is supported by iron. Iron cage. Underneath this is a coil. Underneath this is a coil. So there in a speaker there is a piece of magnet. It is magnet. And what is this? It is a coil. Coil has two ends. These two ends are drawn below, and this coil is wrapped on a diaphragm. It is glued on a diaphragm. This is a diaphragm. This coil is wrapped or adhered to the diaphragm. This thing is diaphragm. What happens when electric signal from mic or from any other device comes to these two wires? These two wires are brought here and one here. But it should be remembered that coil is fixed with this diaphragm. Magnet is fixed with iron support. Magnet is fixed with iron support. Okay. When an electric current goes in, suppose this one is given a positive, this one is given negative. When positive enters the coil in anti-clockwise direction, and that end becomes north, that end of the coil becomes north. So here is north, here again north, north and north repel, the coil goes down, it pushes diaphragm down. If we give alternating current or a signal, that means this point does not remain positive for all times. It goes on changing according to this signal: positive, negative, positive, negative, positive, negative, negative, positive, positive, negative, positive, more negative, less negative, and accordingly this vibrates. This coil vibrates. If this becomes positive, this becomes north, and this goes north, north repel. They go. The coil goes down. If on the other hand, this is given negative signal, this is given negative, and this positive, what happens? This is north, and this becomes south, and they attract. It goes up. When this becomes positive, it becomes north, and coil goes down. When this becomes negative, this becomes south, and coil goes up. With each up, each down, it pulls the diaphragm up and down, thereby it makes a sound. That also we will show you practically in the later classes. In brief, we have seen that a microphone, microphone. Microphone is an piezoelectric crystal, and on this side is one wire, on another side is one wire. When we speak, when we speak, let we make air also here, and some here also. When the man speaks in front of this piezoelectric crystal, it gets compressed, relaxed. With each compression, this becomes positive and negative. With relaxation, this becomes negative and this positive. This signal, if fed to this magnet, this speaker, it make a sound accordingly. This will also will be taught in the later sections. Now, rub it again. How do we produce or make an amplifier? It is a good lesson. We take a microphone here. We take a microphone here. Let we show it by this only. This is a microphone. And from this microphone, two wires emerge. We take a microphone, and also we take a PNP junction transistor. We take a PNP junction or NPN transistor. N, P, and N. This is transistor. Here we have taken mic with two wires and a person speaking here. Let it be she. He or she is speaking here. When she speaks here, what happens? The piezoelectric crystal gets compressed, relaxed according to her voice, and accordingly, signal is transmitted through these two wires. When we feed this weak signal to a transistor made up of N, P, N materials, two N materials, in between is a P material. This transistor amplifies the signal. What it does, it is a transistor, it amplifies the signal. This is microphone. And how it does is that, let we take this one, the negative wire, and upper we take a positive wire. How is it negative and positive? Because we will apply negative voltage of battery to this wire and positive end of battery to upper wire. Let it be 4 cells, one cell, these are 2 cells, three, 4 cells, 4 cells. This is positive and this is negative. Positive end towards this and negative end towards this. Now we have to take a speaker to listen. A speaker, we have shown already, is composed of a bar magnet. Underneath is a coil connected to a diaphragm for vibration. Diaphragm may be of cloth or paper. Now these two wires will go here. This is speaker. As already said that a resistance allows only a part of electric current to flow through it. It blocks the flow of electric current according to its power. Now we have to feed this NPN junction, NPN device according to our wish. How much power is needed in the base, how much is needed in the collector, how much is needed in emitter, we have to decide. This middle one is P, and this one, lower one, is emitter, and the upper one is a collector. This is emitter. It is base here. Base needs very less of positive current, very less. This base needs very less of positive bias. So we have to give very less positive voltage to base, very less positive voltage to base. How? We have to connect here a high resistance, resistance of high value. A high value resistance will allow less electric current to flow down. This is money. This blocks money up downs. This is a resistance, resistance. This is a high resistance. So we have connected a high resistance from this positive terminal. This is positive already from here, battery. We have connected the base to positive terminal through a high resistance, so that only a small part of positive voltage goes to base. But we have connected emitter directly to the negative terminal, minus. To the negative terminal, we have directly connected emitter. This is negative wire. Why this is negative wire? Because we have connected this wire all through to the negative part of this cell. This is negative, positive, negative, positive, negative, positive, negative, positive. These are four cells. Maybe 5, 6, 4 are at least needed. Four cells there. A four cells, negative terminal to this side, positive terminal to this side. So emitter directly to negative, base through a high resistance to positive, and in addition, what? This microphone directly to this base. Microphone one end directly to this base. Another end of microphone directly to this negative terminal. Microphone directly to negative, microphone another terminal directly to the base, and base also through a high resistor to positive terminal, so that a few millivolts of positive charge will flow to base. What will happen when she speaks? Positive charge goes here, already connected positive, it adds positive charge, and when we connect this one, this speaker directly, one wire directly to positive here, and another directly to collector, another directly to collector. What will happen that when she keeps mum, she is silent, no signal flows to base, no signal flows to base. When she speaks, a few millivolts of positive charge flow to this terminal. It makes the base more positive. By making this base more positive, it draws the negative up. Negative is allowed to go to P. And what happens is that the four cells are connected on one side of speaker, other side is N. What happens is the whole voltage of four cells goes through this wire and jumps directly to emitter. When she speaks, whole the voltage of four cells goes through this coil, jumps through N, P, N down. If she keeps mum, this voltage is already present in this, but it is not allowed to flow down by this NPN junction. What is its function here is that by this arrangement, electric current will not flow through this coil to negative side when the lady keeps mum, or when she is silent, or either he or she. Whenever a person speaks, a few millivolts of positive charge goes to base, and it aids this positive charge to go down through this transistor. And what happens by going down, the diaphragm goes down. When it stops, diaphragm goes back. When it goes down, diaphragm goes down. When it stops, diaphragm goes back. So when she speaks, hello, how are you? And in this way, the diaphragm also oscillates. It makes a loud sound. This is the transistor as an amplifier. Later on, we will see how it is given a practical shape and how we will connect this mic and this amplifier transistor speaker and show you in a more detailed view. Let us rub it off. Now, what we will say that how to make the waves travel in space. It needs an oscillator. Chapter is electromagnetic devices and circuits. Electromagnetic devices and circuits. Now it is oscillator. Electromagnetic oscillator. Hartley's Colpitts. There are so many oscillators. For example, Hartley's oscillator, Colpitts oscillator, we have already said that the coil, the inductor, offers a delay. It offers a delay to the flow of electric current. However, the capacitor stores electric current. What happens when we give a parallel combination of a capacitor, condenser, capacitor, when we connect capacitor with a coil means inductor, parallel, when we connected it in parallel combination and give a DC voltage. That DC voltage is stored in condenser. At the same time, according to the delay power, the coil makes this flow from positive to negative terminal. So what happens? What happens then? When we have given DC voltage to a parallel combination of a coil and a condenser. That very DC voltage is stored in condenser or capacitor, but the coil which is connected in parallel, that allows the positive voltage to flow through it towards the other end according to this delay power, and this voltage gets reversed and this voltage gets stored in the condenser in reverse direction according to the delay power. And when it gets stored in the condenser in reverse direction, again the coil allows back flow from that reverse made positive to negative. So this travels back. This going in one direction, again reversing, going again direction, reversing. This makes oscillation across a combination of capacitor and a coil. That means the electric current oscillates in the circuit. This is a coil, conducting coil, and Here it is a condenser, capacitor. Capacitor is shown by two parallel lines in circuit. When we connect these in parallel combination, we have connected a capacitor and a coil. We have connected a capacitor and a coil in parallel combination. And these two terminals, when connected to a DC voltage, once what happens, we will see. When here it is a cell, what will happen when we will connect this negative to this end and the positive to this end through a switch. This is a switch. When we will press it, make a connection so as electric current will flow through this switch and go here. Positive will be stored here. Positive electric current will be stored here and negative current will be stored on the other plate, on the another plate. When we take it off, we break the circuit. When we break circuit, what will happen is that this positive charge is allowed through this coil to travel towards negative. But we have already learned that a coil offers a delay. It causes a delay to flow. How much and how many turns, maximum number of turns, more the number of turns, more will be delay. Less number of turns, less will be delay. If lesser number of turns will be there, lesser will be delay and immediately it will jump here. But what will happen? What will happen? For example, this was positive charge there. Charge was there. This has been allowed to go, and if the number of turns was shorter, number of turns was less, that means the length of this thread was less. What will happen? Immediately, more will be frequency. Immediate will be the reversing order. So what will happen here? When we have switched off, this positive will flow through this wire and down. It will flow down and come to this plate according to the power of delay by this coil. After a few milliseconds, we will see that this whole positive has vanished here and positive had appeared there on the another plate. Negative has appeared on this plate. So coil is already connected. It has not been disconnected. This will again jump back. This positive will jump back there like this oscillation, mechanical oscillation. That is electric oscillation. But when this has jumped there, but it will not remain here. It will jump back. It will jump here and there, here and there, here and there. So ultimately, after some time of offering a resistance by these wires, the current will ultimately fade and stop. It will then stop. This going here, going there, going here, going there, charging plate in this direction, then charging plate in that direction, by current going reversed each time in each cycle. So when current will get reversed here in each cycle, this will become positive again, and here will again come negative, and these cycles will continue indefinitely, thereby making an oscillating electric current. This is fundamental principle of making the electric oscillations. Now, Hartley's oscillator, Colpitt's oscillator, they have devised circuits how to maintain these oscillations, how to maintain these electric oscillations. Means when we will when we will make electric oscillations, they will ultimately fade. But Hartley and Colpitts and many other scientists, especially the English or British or German, whatever we'll say, not Kashmiris, and they have devised how to maintain these oscillations, how to maintain this, so how to amplify these oscillations, how to maintain and sustain these oscillations by use of transistors that we will see in next section. Now we have seen that oscillations are made by parallel combination of capacitor and a coil. Parallel combination of a capacitor and a coil. We have to take again an amplifier made up of N N in between P, N transistor, and here we have to take a wire, positive positive wire. Lower down we have to take another wire, negative wire. Why this is negative? Why this is positive? Because we have to connect cells here. One cell with positive and negative, again another cell positive negative, many cells we have to connect. So here are contacts. Positive we have connected here. This is positive. This is positive. Positive wire. And this one is negative wire because we have connected it to negative. Positive wire and negative wire. This is all the length positive because we have connected it to positive. This is a positive wire here. So this is a positive wire here. And lower down it is a negative wire. What is it? This is a negative wire. Any wire we will take electricity from this wire, it will be negative. Anywhere we will take electricity from above, it will be positive. Now make a parallel combination of capacitor and a coil. We should take smaller turns of coil because we have to make high frequency oscillator. High frequency oscillator or ultra high frequency oscillator needs coil that is that is this inductance means coil of smaller turns. On the contrary, low frequency oscillator needs a coil of many turns. We have to make, let us make a high frequency oscillator. High frequency oscillator. So we will take a few turns only. This is 2-3 turns only. Coil of a few turns, 2-3 turns only. Connect it to a capacitor. Let this be capacitor. Again, this capacitor C, this is inductor L. Parallel, we have connected them in parallel. Parallel means one end of coil and one end of capacitor on either side, another end of coil and another end of capacitor on another side, making two connections only. Now make these oscillations to be amplified by this transistor. It needs that this and this be given directly to negative, this be given to positive but through a high resistance, so that only small voltage will flow to P, to the base. Base should always be given very less positive current, very less, because there is no fun when we will give more positive than it is already on. Why it is given very less positive? Because it should remain under control of this input. It should have very less positive voltage, so that it is dependent on the positive voltage of this input. Here oscillator, when oscillator will oscillate, it will give positive current and this will amplify. When this remains silent, this will not amplify. So we should not give middle piece more positive. We should give it very less or negligible positive. Then connect it through a resistor, but small resistor. This is a small resistor, so that more of these oscillations travel here, more of voltage of oscillator goes here and less of positive will go here, so that the middle PSP is dependent more on this LC circuit than on this positive. So that is why we have given high resistance here, so that less of positive voltage will be given to P, and we have connected small resistor here, so that more voltage will flow from here to here. What is to be done now is that this is to be connected directly to negative. Okay. Again, we have to make similar LC circuit here, because we have to take these oscillations amplified but here. But there should be also such a reservoir which will hold these oscillations there. Otherwise, when you will take water in hand, it will not remain there. This is reservoir for oscillations, just as there is reservoir for water, a tumbler. So similar reservoir you have to keep here of coil and a capacitor. So connect this through a smaller resistance so that more of power will flow. And another so we have connected it here it directly to collector, emitter here it is emitter is directly connected to negative terminal. Collector is connected through this L and C circuit through a lesser resistance. Lesser means it is not offering any appreciable resistance. It is offering least resistance. So what happens? More power will flow through this and go here, but is waiting to flow down. But it is under control of LC circuit. By this combination, it is transistor here. By this combination, what happens is that this positive voltage, this positive voltage travels through this lesser resistance. It does not offer so much resistance. It does not offer so much resistance. It allows immediately. It is smaller, negligible resistance. It of a few ohms, 100 ohms. It allows immediately the voltage to flow through this, and it is waiting here for the ascent, for the consent of transistor, whether it will go down or not. But who will allow is this LC circuit, because this P is under control of this input LC circuit. It is called tank circuit. TANK, tank circuit. Whenever this oscillates, when vibrations come here, this high voltage goes down. When vibrations stop, it stops. When vibrations come, it goes down. Vibrations stop here, this stops here. So whenever it is oscillating, that is oscillating but with high voltage. It is oscillating with less voltage, that is oscillating with high voltage. What happens? That when here these are the frequencies, if this has a graph like this LC circuit is having graph like this. What we get here is the graph like this. So this graph is amplified by that much amplitude. So what we have made is that we have sustained these oscillations, and indeed we have amplified it in many fold, 10, 100, 1,000 fold according to the power of this transistor. This is called oscillator. This is called the oscillator. An important fact about this oscillator is that if you have less number of turns here and smaller capacitor here, the frequency will be high. The frequency will be high. However, if it is so much smaller number of turns and so much smaller capacitor of a few picofarads, pico means 10 raised to 12, if it is in the order of picofarads, picofarads, if it is picofarads and it is in microhenries, what emerges from it is a high frequency, a radio frequency, a radio frequency. Even smaller, you keep here very high frequency, ultra high frequency, that is microwaves. Microwaves have very high frequency but less wavelength. That will be amplified by this transistor, and similar wave, amplified wave, will emerge from here. What will happen here? A strange thing happens. If you connect a rod here, if you connect a rod here, if you connect a rod here, the rod should be half the wavelength. These waves are transmitted in air. These waves are transmitted in air. These waves are here transmitted in air. And what we will get is a transmitting station. So this is oscillator. And next we will see the applications. We will also see the computer, its basics, and electromagnetic induction. Indeed, we will see the alternating current, transformers, and we will go to the basics of the electric current, that electric current not only flows, it is also a static phenomena that is called electrostatics. And what is magnetism? Magnetism is also sometimes static and sometimes it flows. In everyday life, we have seen the light, it is an oscillating electric and magnetic wave at right angles to each other. So, thank you for today. Goodbye.